All right, we're going to start with A2. So A2 says if an electron, so this is the part that's important. If I have an electron, my charge, again, the difference between a proton and an electron is 1.6 times 10 to the negative 19 coulombs. So all this negative means is when I do my sign convention, because I have an electron, I'm going to use my left hand instead of my right hand. So if it's a proton, I use my right hand. If it's an electron, I use my left hand. So an electron in an electric beam experiences a downward force. So F magnetic, and you can abbreviate that any way you want, is 2.0 times 10 to the negative 14 newtons, and this is down. While traveling in a magnetic field, so that's B, 8.3 times 10 to the negative 2 Tesla, and this is west. All these directions mean something. What is the direction and magnitude of the velocity? So the magnitude is how much? I'm going to use the equation for that. And I don't have to bother putting the negative in because that's just going to give me the magnitude. When I get the direction of the velocity, because velocity is a vector quantity, it has both magnitude and direction, now I have to use my hand. But because it's an electron instead of my right hand, I'm using my left. So the first thing I want to do is I write down my basic equation. B is equal to F magnetic divided by QV. Now, because I want to solve for V, I'm going to rearrange the equation to solve for the unknown terms known. So I'm going to multiply both sides by V and divide by B. So V is equal to F magnetic over QB. So this is going to be 2.0 times 10 to the negative 14 newtons divided by 1.6 times 10 to the negative 19 coulombs. Remember, I don't have to put the negative in here because I'm going to do it when I use my sign convention to find the direction. So instead of the right-hand rule, I'm going to use the left. Times 8.3 times 10 to the negative 2 Tesla. So when I multiply this all on my calculator, B comes out to be 1.5 times 10 to the 6 meters per second. But my answer is not complete, because this is just the magnitude, and I need to do the direction. Okay. So remember, everyone put up your left hand. Now, the force is your palm. So now what I want you to do is put your palm down. So you're going to put your hand out, and the palm is going to be facing down. Left hand. Okay. Now, the magnetic field B is your fingers. So that now you're going to point that in the west direction. Remember, your hand has to be like this. Your thumb always has to be perpendicular to your fingers. So you're going to have your thumb down. Your palm is facing down. And B is going to be going west. Now, which way does your thumb go? Your thumb is going north. You're using your left hand. Yeah. Your thumb is going to be going north. So my final answer here is going to be 1.5 times 10 to the 6 meters per second, and this is going to be north. Now, if I was doing this and I was using my right hand, it was a proton, then I would get south. Okay? But this is an electron, so I have to use my left hand. Okay, so that is A2. All right, now we'll look at practice B. So we'll do B1. So B1 says a 6 the length of the wire is equal to 6 meters, and they're telling me the current is 7 amps, but this is going in the positive X direction. The magnetic force is 7.0 times 10 to the negative 6 newtons, and this is going in the negative Y direction. And now they want you to find B. So B again has both magnitude and direction. So B is equal to F magnetic divided by IL. So it's 7.0 times 10 to the negative 6 newtons divided by 7 amps is the current and 6 meters. So B comes out to be 1.7 times 10 to the negative 7 Tesla. But now we need our direction. So I is going in the positive X direction, and F is going in the negative Y direction, and B would then be going in the positive Z direction. What we have to do is every time we do these, we're going to be practicing, you know, is it positive or negative, which right-hand rule are we using, depending upon what we're doing. Practice makes perfect. But remember, when we're dealing with vector quantities, vectors have both magnitude and direction.